And we're live. Welcome everybody.
Hey! Hello!
Hello,
Hello,
hello.
hello!
Yes, indeed. Episode
How are
43.
y'all? Yes,
How are y'all?
43. We missed last week the opportunity to talk about the episode that explains everything because it's the episode
Oh,
40.
the meaning of life.
Mean,
Yeah,
well, the
42.
the meaning of podcast.
Okay, cool. Who have we got? James, Sonic Alchemy, Jeff Slater, Brian Vines, Das Mia, Thomas Moroz,
Yay!
Tetra
Yay!
3D Print, Daffyd, the handy outdoor nerd, Aaron, Colin Hickey, new sub. Thank you, Colin.
Hey!
Here we all are. As usual,
Yes.
it's 1 a.m. for me, and it's what is it? 3 p.m. for you, Ivan.
It's 3 p.m.
3
3
p.m.
p.m.
Lovely.
The comfortable 3 p.m.
Very good. Oh, Ian is here. Kathy O'Malley. Haven't seen Ian for a while, actually.
Hey,
Welcome.
yeah. Welcome.
And Wellbot.
Yeah. Oh yes, he's alive. So
So tell me, everyone, have you all seen Ivan's video for this week? Just put yes
last
or no in
last
the last week.
yeah
I call it this week because it's
yeah
in the last
yeah
7 days.
yeah the last one.
The last video.
Yes, the last video where I try to make I say try where I try to make a
Try.
giant. Yeah, I'm trying
I don't think you
because it's
tried.
not working.
Oh, what do you mean it's not working? Oh,
It's not finished yet.
I understand that. You don't have the
But
bits.
yeah, they are. I have to go and pick them up. The last parts, the Hermes and the super volcano with a zero 0.6 hardened nozzle. 0.6 or 0.8, I'm not sure. But yeah, a thick enough nozzle. Yes.
But you've got the mechanics working well.
The mechanics work much better than I expected. There is some cheating here and there because one cannot make a 72-minute long video. YouTube doesn't like that.
No.
So there are some things hidden, some like back and forth. Some of them can be seen like the result, like the iteration of the 3D printed parts, but not the entire process of like going back and forth, putting it on, removing it, and going back all over again, which takes a pretty decent amount of time. People tend to forget that.
Okay. Yes.
But yes. And this week's theme is when designing a 3D printer, you have to make lots of choices when you are going like from scratch, as I've done. So you have to choose between the bad, the expensive, or the good enough, which is kind of is the conundrum of the DIY maker, because usually when I'm pretty sure that there is people that likes to make stuff and has unlimited budget, limited tools, and unlimited time available, but usually tends to not be the case. Usually, so one of the, and this kind of may sound like I'm holding a grudge, because one comment that has been repeated like I say 50 times in the last video. there are a few things that have been repeating on the comments, but one mainly is the mirror sagging.
Ah,
People keep saying that I should put a reinforcement in the middle of the platform that holds the mirror because people say it's going to sag. So put the reinforcement because we think it's going to sag.
how about you put the reinforcement when it sags? Which is why your tweet said something like, let's talk about does it sag?
Yes. Does it sag or doesn't it? And I did a test before putting the tweet. I did this is completely irrelevant. If it does or if it does not sag, it's not important. Like I did put a ruler, a straight edge, vertically on the bed, and try to in the short distance and try to pass a piece of paper below it. One piece of paper does pass below the ruler, but two don't.
Mm-hmm.
Two don't.
Doesn't.
Two doesn't.
Two doesn't. Yep.
Yes. And there is this thing. Depending on what you are going to print on the machine, you can take or you cannot take that amount of sagging. But it's up to the person making the thing and what he or she knows is going to do with it to decide if that amount of sagging is to be allowed or not.
Correct. So a piece of paper is 0.1 roughly.
I'm not sure. It's 80 grams.
80 GSM.
You can, yeah. The thing that I replied to one comment is because it's not magic. Okay. Sometimes you are doing magic and other times you are not. You can get the amount of sagging that a piece of glass that size gets in the middle by testing it, as I've done. You can do finite element analysis simulation in Fusion 360, for example, allows that. You can get the formula and do the calculation. Get the result of any of those three, or I'm sure there are more, and get the exact amount and decide if it is good enough or not. But what you might be tempted to do is to take note of all those people commenting that and put a couple of reinforcements in there. Not one, you can put two. And then start trying to finish the printer and not having enough profiles to do the rest of the printer, for example. Mm-hmm. Because you have one of the limitations. You have limited budget.
Yep.
Or you might be trying to get the printer running for certain event or to make a part that you need for a certain time and not having enough time to finish the printer on time because you did invest some time on doing that, for example, going back and forth.
Understand.
So the thing is that you can have, you can do what I've done, is being bold enough to place the, I've done something that probably, I'd say 0.1% of the people in the comments have done, that is holding a 5mm sheet of glass that is 800 by 600 millimeters. I have held it.
Yes.
I have held it.
Held, yes,
held
correct.
It,
yep.
held it in my hands. And I know how much, like, it's not like a sheet of paper.
No, of course.
That the glass is pretty stiff and pretty hard.
Yeah.
So the first thing that you can do is like hold it in your hands and you realize this is not bending. And place it in there and just take a look from the side and say, this is not bending. And then if people tell you this is sagging, you can put a ruler on top of it and try to pass a piece of paper below it and say, this is not sagging, and then go on with your life. But the temptation may be, if you read all those comments and you haven't never done a 3D printer, say, okay, sagging is first very important because 50 people have commented about sagging. And then sagging is something that that I have to take care of. So I will get extra complications. I will put a reinforcement below the bed. Or maybe I will do one of the things that people have recommended. Put a sheet of aluminum, heat up the aluminum, and then put the glass on top of it. Which is a mistake. It's a very bad mistake. Because the expansion coefficient of the glass and the aluminum are pretty different. The expansion of the aluminum, I think it's 1 millimeter per meter per degree, something like it's absurd. And if you have a constrained piece of aluminum constrained on the sides, and you heat it up from 25 degrees to, let's say, 75 degrees, you get an expansion in this dimension of 2 millimeters. And if it is constrained on the sides, it's going to do this.
Bowing, yes, of course.
And then you will have a piece of glass that is not sagging, or is not sagging enough to absorb that, floating on top of the aluminum.
Absolutely.
Which coincidentally has happened to me before.
This is the voice of experience.
Because 0.1% of the people that are in the comments have built a 3D printer before. And there are comments that are like, I've never done this before, but you should take a look at this.
Yeah.
And there are comments that say, this is going to sag.
Mm-hmm.
And then there are comments like, this is not going to work. Like, straight away.
Sure.
But I don't want those comments to discourage people from making stuff.
No.
Because people tend to read those things and say, if this guy that makes all this stuff doesn't know about sagging, it makes these mistakes, like, I will not be able to do that. But that's where the little bit of boldness will help you. Just try it.
Sure.
Try it.
Yeah.
Put the mirror. Let it sag. Let it sag. No, we are going to be copyright stricken. Copyright struck.
No,
Okay.
That's a good one. Yeah, there'll be a strike against us because of copyright.
Okay. even you are like, okay. So let it sag and put the silicone heat bed wherever you want. Heat up the glass and try to print. Because in this case, the worst thing that could happen is that you have to go back and add another piece of aluminum under it, which is not that simple in my design because I'm a little bit tight on space. But that will save you. You will gain the knowledge about whether sagging is important, if sagging happens, and if you have to worry about it. And then you will gain confidence because you know that you can take the risk, and if it doesn't work, you can solve it.
Absolutely.
Which is awesome, because lots of people say, I've read one of the comments was, how can you make all those cuts by hand and all those holes drilled by hand and all of them be straight? There is a mistake in that phrase.
They don't have to be straight.
No,
but it just needs to be square when you tighten it up.
Yeah, you have to be straight enough for when you fasten the bolt, whatever piece is sitting against the profile gets like slightly bent and goes square with the profile.
It's aluminium.
And another trick that you can use, because I cannot explain everything, but if you have to, like the wheels that go on the rails to slide the bed.
Yep. Which is genius, by the way.
I think it's the thing that I'm the most proud on the entire design.
That was really cool.
And I'm really thinking that someone at Reality
Yep.
is like, how didn't we think of that earlier? Because it requires even less material.
Yeah, absolutely.
So I think it's well, when I was trying to drive one of those, like those are threaded, and those have to be the exact diameter to be threaded at the metric that I'm trying to do.
Yep.
But the ones on the sides that make the squares, the hole that the bolt goes through, if the bolt is 5 millimeters, the hole is 7 millimeters.
Mm-hmm.
Because the only thing that you need to do is, when you are having this, is those 7 millimeters will give the profile that has the 7 millimeter hole the enough play to go one against the other.
Yep.
Then you fasten it, it goes to place. It goes square.
Yes.
Because the cut on the profile is square. I wouldn't recommend to do the cuts by hand on this design, because the squareness of the entire frame is given by how good the hacksaw, the
drop saw or circular saw or drop saw.
Circular, yeah. The drop saw can make. If the drop saw can make perfect 90-degree cuts, then the entire frame will be square.
Yep.
Or you will have enough play to adjust everything. But if you cannot make 90-degree angles, that's trickier. But yeah, having to go for perfect when perfect is not required will make the design and the parts to buy expensive.
Yes.
So you can do it wrong, you can do it expensive, and then you can aim for the good enough. Which when you search in forums for the maker community and say, it's a bit hard because there is always one voice that is more authoritative than the rest that says this is how it's made. But that's never the case.
Yep.
Because if you are trying to make an under 3, an under 3 sized printer can be done with chopsticks because it's really small.
Yes.
And you can just do it however you want because it's going to be stiff. But one thing that I'm not proud of in this design is that I used in many of the parts of the printer single 2020 V slots or G slots.
Yeah.
And that's pretty flimsy. That's why I had to add reinforcements in the base.
Yeah.
But I went bold enough to not put anything and go straight with 2020. And then you can see me in one point trying to see if the profiles are straight in the video. Because when I did present them in the machine with the bed in, they were all making curves.
Okay.
That's why it is double. But the thing is, if you can add a second profile, and buying straight 4020 is more expensive than having 2020, you can go with the 2020, and if it bends, add another piece.
So is two 2020s more expensive than a 2040 for the same length?
Yes. Yes.
Okay.
But going for 4020 straight away will make you take the punch and pay for them in advance.
Yes.
Because you have assumed that because when I'm building, I'm always in a hurry and I need all the material in here and I need it now. That's why many of the parts on the machine are on the machine, because I didn't have enough time to wait for them to arrive. But if you can buy the 2020, build it, and if it doesn't work, you can buy another 2020 or swap for a 4020. You always have the chance to be cheap, to have more money to buy a better extruder or to buy a better hot end or whatever.
Sure. And you can make it rigid by adding another 2020 if you need.
Oh yes, yes. Well, now that you talk about rigidity, the Z-axis, the gantry, the entire, the gantry. Lots of people were complaining that I did that hanging there without putting extra reinforcements to make triangles.
Oh, the bar,
so it doesn't back and forth. But I've seen that in the new Creality CR10, the new version of the same printer, the new iteration. They have put a couple of kind of struts in there to add rigidity to the printer. But I cannot find a single reason, or I cannot seem to find which force is applied to the gantry on that plane to justify adding any reinforcement.
Sure.
Because there is nothing pushing against that.
Yep.
I cannot see it because it's the bed which moves back and forth by this that is attached to the square part of the frame that is in the bottom.
Yes.
And the only thing that I can see rubbing, the head laying down the filament, rubbing against the part, maybe putting some strain on the gantry, but that is going to be grams.
But yeah, it's not enough to deflect the whole.
There is no way.
No.
That will not deflect a 2 meter high.
No.
And by the way, that gantry, the vertical posts, are recycled from a Tevo Tornado.
Okay.
So they are the exact height of a Tevo tornado.
Okay.
If those were good enough for a Tevo tornado, those are good for this printer because the forces are the same.
Yes. Totally.
And it even has more mass, so it's harder to inflict any movement on them. So I'd say to whomever is trying to build its own 3D printer, not copying my design, but going from scratch, or kind of like maybe getting a CR10 and making it bigger, or trying to make a Corex Y that is kind of like the thing that everybody said in the comments. Like, why didn't you do a Corex Y? I tend to say why. People have prepared some kind of smart things, but I'm not focused on the speed. But there is no universal good. If you are trying to make your printer, there is not a single way that is good to make your printer.
Additionally, the commenters don't know what's in your mind as to what you are building or printing. They're thinking their own use case, not your use case.
Yes. If you want to print a castle with a dragon on top of the tower at 4,000 millimeters per second, maybe this is not the printer. Maybe this is not the printer. But usually, I cannot imagine something that is going to be printed in this size of a printer that requires very high-speed jerking on the go JT go.
Yeah, go caffeine.
I cannot imagine. Yeah, I cannot imagine the bed going. Which print is going to require that? Something that is really small.
Yeah.
And I'm aiming for patience. Yes.
Oh, I've just realised I can see the green screen on your Skype window. Let me address that slightly.
I can move myself.
No, that's
Do you
right.
want me to move myself?
No, it's right. I got it. I'll do that there, and there, because I don't want to scale you too much, because we can't have you scaled. There we go. Yes, I like the control, Jordan. That is absolutely correct.
Yes. Yeah, but and Volvo says that the aesthetics of the prints, if you go slow enough to not let anything deflect or bend or anything, then the prints will look good. People were complaining about ringing on the print. Well,
yes, terrific. And this, Ivan, reprint your tank. It's got ringing. Redo that. Redo that 4,500 hours.
There are a few shitty prints on that tank.
Yeah.
I'm not talking about bad. I'm talking about holes in the layers. Holes. But I will not reprint a 6-day part because of that, because it works.
Yep.
But even if you are trying to go for really high aesthetical outcome, you have to take into account that there are many factors that affect ringing. Well, one of the common solutions that I will say between quotes experts say it is good for to avoid ringing is to affix the bed to something really heavy, or to drill to screw the base of the printer to a very heavy table. But that is not the best solution. You can add springs that are tuned to a resonant frequency that is much higher or much lower than the inertial resonant frequency of the printer, and you could still solve that issue in a much better way. Because whenever the printer tries to go against its own weight and flex it, it will give, which is even better, as long as you don't go resonant, which has happened to me before. Lots of things have happened to me before.
And this again is why you know what you can do and what you can't do.
Yeah, I've thought of a few examples to encourage people to not always listen. You have to listen to experts. But I read this the other day in a tweet. I don't remember from whom. You shouldn't let the people that say it can be done to interfere with the people that is doing it.
Absolutely.
If you are trying to make something, because there are a lot of couch engineers. people that are in the couch
Yes.
and say, that's not how it's done. What was the last time that you did something?
Yeah.
That's not how it works. So one of the examples that I have on my list is when you are trying to make a bridge, and if I ask people, what's the best way of making bridges? And you could say, okay, steel reinforced concrete with very thick concrete pillars, but then you have gone immediately to think about a bridge that has to have cars and trucks going over it. But it could be a pedestrian bridge that goes above a river. And with pieces of wood and ropes, it will be good enough. Or, well, what's the best way to attach a box that you bought on Amazon to your bike with a piece of rope, whichever rope you have? Is that rope good enough to climb a wall? No, because the requirements are pretty different. If you are going to hang your life from a rope, it's not the same thing that attaching a box to a bike. So the perfect rope as the perfect printer or the right way of doing making a printer, they are not unique.
No, it's based on the requirements.
Yeah, you could get a very thin piece of thread, attach the box to your bike with that very thin piece of thread, and you can go home. The thread breaks, and the box will fall off your bike. But the consequences, unless you are buying like glass vases from Amazon, it's not going to be really terrible. But if you use a very cheap rope when you are climbing it and it breaks, you will kind of break your neck. If you use the climbing rope to attach things to your bike, your things will never fall off your bike, but you are going to spend a lot of money on something that is not required.
Absolutely.
So, the bad, the expensive, and then there is the regular rope, the good enough.
Yeah, what you have on hand that's reasonable for the job.
Yeah. Usually when people ask me what's the best tool to do the job, I tend to say always the one that you have on hand.
Yeah.
Like, if it's in your, use it as a hammer, please. Yes, I have lots of examples. The racing car cage. When you have a racing car and you are going to compete, they make you have a cage, a steel cage around you.
Roll bar.
Lots of 5-point seat belts, helmet, the hands. That could be used in the street in a regular car, and it would be much safer. But that's extremely overkill. You could ask people to have that. Could you imagine having to put a hand
device?
Helmet.
No.
To go to buy the bread to the store. That would be insane. Yeah.
Yep.
Yes. Speed on prints. There are several ways to get speed on a print because people say you will have to print really slow. Have you seen the latest video from Stefan from CNC Kitchen?
No.
Haven't seen it either, but I've read an article and I've seen the thumbnail, and I think he's right. You can alter the extrusion thickness, not the nozzle.
Understand? Yeah.
You can adjust the extrusion width and get much stiffer parts and print much faster without doing anything else, without the nozzle traveling faster.
So as long as the extruder can keep up.
Yes.
Okay. Yep.
Yes. And again, we are all the time talking about trade-offs.
Mm-hmm.
Because if you have a Bowden with a sheet extruder that skips steps and a hot end that cannot keep hot at high throughputs, then there is the trade. You can add a more expensive extruder, a more powerful block on the hot end. There are many things that can be done.
Sure.
But if you have ringing, one of the things that you can do to print faster but not move the entire machine faster is to add a bigger extrusion width to your settings and print and print faster.
Yep.
Without ringing. And that's nice. And speed and acceleration are not the same.
No.
Because
Speed is a constant. In terms of, we would say millimeters per second.
But you can have a very heavy bed that is not very stable and print really fast as long as you don't have very high changes, large changes on speed, fast changes on speed, which is the acceleration. That is where ringing comes from. If you're printing something really large that hasn't have very small or sharp features, you will still be able to go very fast without making very sudden changes on lots of sudden changes on speed.
Yep.
Which will end up having a nice print.
Mm-hmm.
That's why you always need to know what you are going to print on your printers, people, and advised. Yes. And one of the comments that I read, and I learned a lot of the comments make me think a lot, because I read one guy that said that he had, I think, something like CR10 or something similar, and he had improved his CR10 by switching to MDN 15 rails on a CR10.
Okay.
My CNC machine has MDN 12, which simply means the width of the carriages.
Yes.
So the carriages on a CR10 that has the largest race is 400 millimeters has MDN 15, which is in the three cases that we are applying now, the expensive, but I think he is going so expensive that is counterproductive.
Yes.
Because each one of those blocks are huge and are really heavy, and you have to accelerate the blocks. Mm-hmm. And then you start like, I will put a bigger motor, more powerful motor, I will put two motors, and then everything gets out of control.
Yep.
Without making any sense. Because another thing that I added is data sheets. Did I say it correctly?
You said it. You said it enough that it sounded like shits, but data sheets is correct. Yes.
Okay. How many times or how often do you read a data sheet? Zero. There's this thing where I'd say 99% of the parts that can be used in an industrial environment have data sheets. And rails and rail carriages, the blocks, have in their data sheets their maximum capabilities. Like if you have I would say, I need something that looks. If you have a block, they will tell you how much weight it can withstand in this direction.
Yep.
How much can you twist it like this? How much can you twist it like this? How much can you twist it like this? And it will tell you that in static and dynamic situations.
In other words, don't bother. We don't need to know.
The thing is, if you can get the data sheet of your block from Highwing, for example, is a really popular manufacturer.
Yep.
You will see that in an MDN 15, you maybe can put like in dynamic situation, maybe 700 kilos in this direction.
Yes.
Like in maybe an MDN 12 is 400 kilos.
Yep.
Yes, that's counterproductive. That's too much. And maybe even the grease and the ball retention mechanisms will induce a friction in the mechanism that would not be that important for a mechanism that has to push against 700 kilos, but something that has to push about a kilo of a bed.
Yeah, 700 grams.
It will increase the amount of power required to do the same job, because you decided to use blocks that are extremely overkill. Extremely. Because in a 3D printer, there are no dynamic forces. It's nothing.
Yeah.
in that scale. Yes, people. Yes, data sheets. Yeah, Soviet ICs, the best data sheets. And you have the same for the LM12 UUs, the LM8 UUs, which are the pairings that go with the 8mm and 12mm calibrated rails.
On the rods,
Almost all the DIY printers from the past use those.
Yep.
And those are nice. And one thing that I did use was press fitting those in 3D printed parts.
Oh yeah.
Because by datasheet definition, you cannot C-clamp those.
Because it theoretically distorts them.
Yeah, you induce a kind of an egg shape on them if you don't do it right.
Yep.
And they start going not so smooth. But then there are the
IGUS,
the IGUS friction bearings that require to be press fitted with a very tight tolerance. And I did buy a bunch of those for my old printer, the first one that I did.
Yep.
And I couldn't print precisely enough holes to press fit them, so I could use them on my rails. Either they were too tight and it didn't slide, or they were too loose and they had like the clinky thing.
So they are absolute precision.
They require absolute precision.
Yeah, require,
like the precision, that's like the thing is that the precision doesn't come from the part, but from the block where you insert it.
Yep.
I did receive one 3D printer for review that was assembled with those bearings, and I was assembling it and switched, put the wiring, put everything on, and the Z axis wasn't moving up and down. It was skipping steps, making the noise like ka-ka-ka-ka-ka. And I couldn't figure out why, because everything was assembled. Then I removed the Z axis rods and tried to lift the bridge with nothing attached to it.
Yep.
And they didn't slide because the bearings were press fitted in the blocks that made the bridge, and the holes were too small, so it didn't slide.
Ah, okay.
I had to do maybe 10 kilos to remove the bearing from the rod.
Okay.
It's insane, insanely, yeah. And they did send me that printer for review.
Oh, I didn't see that review.
Them, I didn't make
a review. I know, that's my point.
Yeah, yeah. I told them like at least I need a printer that moves to make a review.
Yep. So that's fair.
Yes, yes. So yes. Oh, it said that, and there is this other thing that read a lot in the comments. That makes me really sad, because there is people saying like, I don't have a 3D printer and I want to make one, and I'm saving until I can buy X something. And usually that something is insanely expensive.
That sounds like a Prusa.
Well, yes.
Typically, that's what people would aspire to.
Yeah, like if you are saving to pay for components that will make you a €1,500 3D printer, and you really want a 3D printer, you can make one with the 10th of the budget.
Yep.
And you will have a 3D printer, a nice 3D printer that works. Because usually there is this trade-off, like, or I have the time or I have the money. Usually you don't have both, but it was kind of sad, because there's people like, they are willing to put the effort, and they maybe lack the knowledge to distinguish between the perfect part or a part that will be good enough. That's kind of a little bit of a sad thing. So yeah, and I've seen in my life, I've seen a lot of projects that because they were trying to have it all.
Yeah.
Like until I don't have like a Duet 3 and a Volcano and a Bond extruder and the diamond nozzle and one bump systems, metal, whatever bed, I will not make the printer. and they never have the printer because they don't have the resources. They lose interest, and that's kind of sad because you could go with much less.
Absolutely.
That's
Even the ANET A8, which was my second printer, but it was the first one I built from a
yes.
kit, was a terrific learning experience. I did a lot of research. I learnt a lot just through fear because of,
Yeah.
everyone going, oh, it's going to catch fire. Although the problem hadn't surfaced when the ANETs first came out. It was sometime later that people started poking around the firmware.
Yeah, but if usually that's the advice or that I will listen to. Like if people say the printer can catch fire because of this, I will pay attention to that.
Of course.
But I'd rather have and right now I'd rather have an ANET A8 than nothing.
Of course.
You can put the time and you can like make it a little bit better of a printer, but the prints weren't bad.
Oh, the prints were fine.
Yeah, the acrylic and the electronics and the connectors, everything was a bit shitty.
Yeah.
But it did print.
Yeah.
At least for me, it did print.
No, I got it to print too.
So, yeah. So yes. So I have here don't take advice from couch engineers and people like that. But I'd say don't take bad advice from couch engineers.
Yep.
And I'm not saying about retired engineers that are on a couch. I'm talking about people that have never done anything, because usually that advice is discouraging.
Yep.
And that's not good. And the last thing that I have in my list is what I call, and I think I've talked about this before, is the ladder of knowledge. If you are here, you have a certain amount of knowledge. Then there is the things that you can make, that you can explain, that you can understand. But usually on that ladder, if you try to jump too many steps at once, it's more probably to fail than if you try to go step by step. So if you know how to make a Cartesian 3D printer, don't try to go straight to make 2 meter by 2 meter by 2 meter printers that as I've seen.
Sure.
Like being able to build an ANET A8 and because all the parts came in the box, and being able to scale that to a ginormous printer is usually not the best advice.
No.
You can go because, well, at least you will learn a lot. But usually taking smaller steps is more recommendable.
Yes, I would agree.
Because people say, I've read people saying, I don't have a 3D printer and I was thinking about building one. I will build yours. You are insane. You are going to go with an incredibly large 3D printer that has twice as motors as any other printer. So you will not be able to go with RAMs or anything like that. That's insane. Hey, but go. At least they will learn a lot. Yeah. And nobody commented that they downloaded the file. I left the files on my. Usually people ask for the files, and when I put the files, nobody says anything. Why?
So the files, you put the links,
yes.
And are you saying no one downloaded the files?
No, I don't know, but nobody said anything.
Ah, okay.
Like I just downloaded the files and I cannot understand anything, something like that.
Ah, I see. Or thanks for the files.
Oh yeah. That would have been nice.
Yeah, thanks for the files.
The RAM support. Yeah, and this is a CR10 replica.
I understand.
When I'm finished, like the carriage is usually the most difficult part, because depending on which extruder and hot end you are going to put on it, you will need different attachments. But I did leave the dummy carriage that is on the printer right now, so anyone can modify it, because I left the sources of the thing.
Mm-hmm.
So if someone wants to modify it, they will be able to modify it, and all the little, like the bracket for the Z-axis nut, motor brackets, everything is in there, and you could build straight a CR10 with this. It doesn't need to be this ginormous 3D printer.
No. You just change the
So
dimensions accordingly. Someone
yeah,
would make a spreadsheet that calculates all the lengths.
but by my experience, that's not even necessary,
I don't think so.
because you can easily see what limits the design. The first thing that I did was decide which bed size I was going to use,
Yep.
and then go back from that.
I was going to say you work backwards based on what glass or surface you can get, what
Yes,
heater you can get, whether it's silicon or something that's pre-wired.
I I I skipped that step
Yeah, yeah,
and went
I know.
to look for one back. But yeah, yeah, that was yeah. And I had one comment. I read all the comments, asking me where do you bought that glass? Free buy locally.
Yeah,
I
absolutely.
cannot believe that you live in a community that doesn't have people that need mirrors. That's it. Like, if you needed a mirror, where would you buy a mirror?
IKEA.
No, IKEA will never sell you a mirror that is the size that you need.
No, no. You said if I wanted a mirror, where would I buy it? I would buy it at IKEA.
Yeah, 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 yeah,
have
yeah.
have
If
you
you,
n-
if you,
have you not used IKEA mirrors on your printers for a long time?
yes, but before using IKEA mirrors, what I did was cut my own mirrors.
Ah, okay.
And if you want to cut mirrors, and you have one of those screechy wheelie things
Yes,
that cut
scratchy
mirrors,
wheelie thing. Yes, good description.
use oil and do
One cut.
one single cut that is very with a lot of pressure.
Pressure.
One single pass. Use oil. Very important.
Use oil. Okay.
Use oil. But there are places that sell glass and mirrors and stuff
No.
locally.
No.
Yes, they are.
Get out of town.
They are called cristalerías in Spanish. I don't know.
Glaziers.
Yeah, you can go to one of those, and they will make you pay for your mirror. How much do you think it was this glass? The one that I have.
Oh, the 800 by 500.
Try to guess in euros. Venga, come on.
15 euros.
We remove the n, the n at the end.
15.
It was 50 euros.
50.
50.
Yeah.
Yes.
Oh.
Yes. 30, 20.
There you go.
It was 50.
James.
Yay.
James got it.
Yay. Yeah. What's a little bit more expensive, but it's usually I use 3 millimeter mirrors on my printers, and that's IKEA. The IKEA ones, I think they are 4. I'm not sure.
That was for Brian Vines specifically.
Okay. Yeah. This one was 5 millimeter mirror.
Yeah.
Because the glacier told me that they will not make a 3 millimeter mirror for me that size.
You know why? Because 3 millimeters would sag.
That's it. Yeah. Sorry about that.
Brian's asked a question. Is the oil to catch the shards of glass, or is the oil to do something magical?
It's for something magical.
Okay.
Because, and I've read about this. The thing is, when you make the cut, the crevice,
yep.
The crevice that you make in the glass, the walls, as they have been ripped instantly, they heat up to an insane temperature, but only in the surface.
Yep.
The thing is, the oil cools down very rapidly that crevice, so it becomes brittle instead of slowly cooling down, which will make it soft. And it being brittle is what makes when you apply the pressure to break the glass.
So the cut, it's already broken by the time you try and break it.
Yes. Yes, yes. But instead of, because if it is soft, it could withstand the bending pressure and induce another fracture path for the glass to break,
Yep.
which happens a lot. They think that you are trying to make a very straight line and you have like a bump because
Yep.
the oil.
Oil.
Yes,
Okay.
yes, oil. Yes, yes. And it took me a while, but now I can confidently cut any glass that I want
Okay.
in a straight line.
Yeah,
In a
okay, good. I'm
right.
glad. Have you
I've
ever
never tried to make.
have you ever drilled glass?
Uh,
Say 8 millimeter hole.
no, oh no, no,
Okay, either have I. I'm just asking the question.
no. And I think once when I was, I don't. Well, let's say I will not tell you where did I get the glass, but I once tried to cut tempered glass with this system
Okay.
in a student flat in the kitchen, in top of the kitchen table. It was a pane that was maybe 2 by 1 meters.
So a
The
windscreen.
pane,
It was
the
a
pane.
windscreen.
No, it was flat. It was
Oh,
flat.
okay. All right, good.
It was on top of the table, and we did the cut, and there were two people on top of the glass, on top of the table. Another two people were on the me and another guy on the floor, trying to crack it, and we already had scored the glass.
Yeah, yeah, yeah.
And when we did put the pressure, it break into a million pieces
Yeah, yeah.
because it was tempered glass,
Yep.
and we were stupid and we knew nothing. We had to like maybe 15, 20 trash bags full of small shards of glass.
Wow.
Oh, can you imagine? The two guys that were on four legs on top of the glass,
Yeah.
with their hands on all the shards, their legs on all the shards on top of the table. Was insane.
Wow.
Yeah. The student life. Yes.
Very good.
Yeah. I should have had supervision until 30, my 30s.
Okay.
It would have been probably safer. Yes. So yeah. I'm done talking. Now you have to talk for 8 minutes straight.
No, no.
No, you have.
7 minutes and 7 seconds. Well, there's a few other people that have come along. Sam Taylor is here. Jim is here. The Edge of Tech. Who did I miss before? Russ is here. I Dig 3D. Camille is here. Thank you for the subscription also. Mr. B, I didn't say hello to Ryan yet. I did see him, but Maya Makes.
There is a question. There is a question
An actual question.
From Colin Hickes. He has he says, I think a lot of viewers want a list of materials and links to where to buy it. So the correct, yeah. There is always a fear of ordering the wrong thing or overpaying. Yes,
I would agree.
No.
I would agree almost 100% with that.
Yes and no. The thing is that I'm from Spain,
So
I'd say I buy lots of things from eBay Spain. So telling you where I did buy those things will not be very useful. Will not be, and I think that everyone has to do their due diligence when trying to make something. Like, this is not a kit. There is not something that you can I will give you a list, buy everything in that list, and you will be able to make the thing.
Sure, but not a list of suppliers. A material. If you said I need NEMA 17 or NEMA 23 or whatever, they can source it. No one's saying they must buy it from the same organisation that you bought it from.
Would you mind asking me which NEMA 17 motors are on the machine?
Ivan, which NEMA 17 motors do you have on your machine?
The ones that I already had in a box.
Aha.
You can ask me.
But they are NEMA 17, are they not?
Yes, they are.
Okay, so
if you cannot
guess. Go on.
If you cannot guess that those are NEMA 17 motors from the video,
no,
then you need to read.
No. That's wrong. What if literally someone has bought a printer, and
Yes.
they're following everybody. They're following you and 3D Maker Noob and Printing Nerd and Angus and how are they
Yeah.
going to know that's a NEMA 17? They don't know that yet.
Okay. Okay. Fair enough.
They can't physically know that until they know it.
Yes, that's right. That's right. Yes.
But that's why
I'd
bill of
say,
materials is okay, not
yeah,
suppliers.
yeah, yeah. I think a bill of materials would be pretty easy to make.
Yeah.
Yes.
Anyway.
Not bolts. Not bolts. Bolts. No, I will not make bolts.
No.
I'm doing that work with the CNC machine, and I'm about to blow my head off. It's there are too many screws on
Oh,
that thing.
absolutely. And please buy from China a box of various M3, M4, M5, M6, and washers and nuts and
No,
Nylex nuts,
no. Go to
Nylock
your
nuts.
local
Sorry.
hardware store and
No,
buy screws.
you are insane.
Please.
You've heard
Yeah,
me complain about shipping,
yeah,
buying metric
yeah.
stuff.
That would be
It's like
insane.
$1 each. You go to the hardware shop, it's $1 each.
But there are yeah. But one thing that I've learned with the time is that there are for all these kind of stuffs there are two different kinds of places to buy.
Okay.
Because if you have a company near where you live, near I'd say in a 50-kilometer radius,
Yep.
that is manufacturing machines, for example, they buy their hardware local, but they do it from an industrial hardware store.
Right.
And those are two completely different beasts.
Yep.
They will give you a hard time trying to order, because like you will go and say, okay, I want 5 millimeter screws with this voice. It will be small. I'm behind the counter. I want 5 millimeter screws. That's the first time that happens, and he will start throwing questions at you. Which length? He will say 40 millimeters. Okay, which kind of head? Hexagonal, Allen,
Cap
blob,
head.
whatever. Yeah, like tapered. I don't know. The regular one. That happens. But then you have heard the words. You have heard X tapered Allen, and then you will go back home and get the MasterCard catalog and learn your screw heads.
Absolutely.
And the next time you go there, you will ask for M5 by 40 X head regular steel screws.
And give them to me now. God damn it.
Now,
Yeah.
with this voice.
Yeah.
It's now.
Now, yeah.
So, yeah. So, and the thing is, they will expect you to buy maybe 100 bolts at once.
Yep.
But they can sell you one.
Yeah.
They will sell you one.
Could I have 4?
So,
But I'll have 5, so I've got a spare one.
one, yeah, because it will fall behind the table. I don't reach because I have small hands. Yeah, yeah,
Very good.
yeah. Yeah. So buy local, but try to find where the companies buy.
Sure.
Yeah.
I understand
it's
that.
it's a little bit scarier, but yeah. And that's good for many things, because it's easier to go through IKEA and grab a box of mirrors. But the guy on the glacier did cut me an 820 by 580 millimeter glass. That's not in stock anywhere.
No, of course. But that's a specialist thing.
That's my special thing.
I understand.
Yeah, and when they give me the glass and look, I always say it's for a 3D printer. I say I will not put a mirror on my wall, or on top of my bed or something weird like that.
Yep.
It's for my 3D.
Yeah, exactly right. I'm not using it for
And
any old.
And they couldn't care less.
Nah. That's
Nah.
like, give me my €50, thanks.
Yeah, and get out of here.
Yeah.
Okay.
Give me cash. G'day, Mitch. How you going?
Yeah.
Oh, I missed the Tinker Dad too from earlier.
Yeah. But I think once the printer works, I will. Yeah, I can easily make a bill of materials.
Yep.
Yes. No bolts.
The the thing that Mitch has said, it's cheaper to drill a hole in pennies in the US to make washers than buying washers.
Oh yes, here too.
Yeah. My,
And in here, the small coins in here, I think it's these ones in here. There are 1 cent, 2 cents, and 5 cents.
yeah.
Those are, the interior is nickel, I think. The exterior is copper. They are magnetic, and they are and solder sticks to them.
Wow.
You can do so many things with this that are not legal. That is insane.
Okay. Because
Yeah.
we discontinued 1, 2, and I think 5 cent pieces has been discontinued mostly.
These are still legal.
Yeah. They're still legal, but they're not in circulation.
Ah, okay. Yeah, these are. So yeah.
The Tinker Dad.
Oh yeah.
When I bought my mirror, yeah, I bought it for lab equipment.
That you have to be careful, because if you say that in advance, instead of 50 euros, it could be 100.
Yeah, yeah. Add the 0 this time.
Yeah, yeah. It's made of special glass made for lab equipment.
Yeah, yeah, exactly.
Okay. Yeah.
Mitch is funny. You use US dollars as shim material. So
Yeah. Yes.
yeah, well, but I think you're right. I think 5 cents is still
When I,
kicking around.
when I went on holidays in the spring with the family, we did rent an Airbnb, one of those Airbnb thingies where you can stay. And they had a microwave.
I want to know, did they have mirrors on the ceiling of this one, or just for
No?
their 3D printers?
No, it was a family.
Okay, good, excellent.
Yeah, yeah. No. They had a microwave oven, and the microwave oven didn't work.
Okay.
And you know me, I had to like try to find why it wasn't starting.
Okay.
And the thing is, at least here in Europe, most of the microwave ovens have in the door a couple of hooks
Yep.
that act as a latch and as a safety device
Sure.
to see if the door is closed.
Yep.
And the one was both were mechanical and one was the safety. And the one that was the safety didn't have the hook.
Yes.
It was broken.
Yep.
So you couldn't start the microwave oven because of that. But it seems that the previous guest in the apartment decided that trying to stack a 5-cent coin in the hole to cheat the safety of the microwave oven was a good idea.
So you found a 5 cent piece in there.
In there, yes. And I called the host and say, look, the microwave oven doesn't work. And it seems that someone, I wasn't accusing anyone, someone tried to fix it by putting a coin in the safety device of this very dangerous home appliance. And they just they did buy another one and came with it, like they swapped it.
Okay.
But it was really funny trying to fix something like, because a microwave oven, as long as the Faraday cage remains intact, is a pretty safe device.
Yep.
No matter how close you are. But once you cheat the safety, if you can switch on a microwave oven with the door open, that's extremely dangerous.
Well, that's how you heat your bed,
Yeah.
as discussed previously.
Yeah. That was kind of like yeah, we talked about that. Yes. Don't do that. And you can go to bed now, Kitty.
No, we're going to talk for another hour, you and I, as usual. And we've got a holiday. Melbourne has a holiday.
Oh yeah.
Yeah.
No, but you have to be fresh and awake for the race.
The race is at 3 p.m.
My time or your time?
My time, my 3 p.m., not yours.
Yes.
All right.
Upgrade. What S upgrade? What they are talking about?
The mosaic. Is the 4 days up already? No. I got a thing.
What?
I got an email the other day. We'll let you know in 4 days.
About what?
Palette or mosaic.
Palette 2S. Yes, palette 2. No, I don't know.
Oh wow, it's time. Okay,
Yeah.
I'm reading the email.
Okay.
That means I've got the email as well, no doubt. But,
Okay.
all
I'm
right,
pretty sure. I didn't.
boys,
Okay.
boys and girls, which I don't think there's any girls today. Oh, Mia was here, but then she went. How dare her?
Yeah.
But that's all right. All right.
That's because I talk all the time. Yeah.
Thank you, one and all. We will
Thank
hopefully
you.
see you next week. All right. Bye
If weather
bye.
allows. Bye.